Now, the next type of function calculations that we need to say is LOD expressions, which are short forms for level of detail expressions. Uh, just like basic expressions, LOD expressions allow you to compute values at the data source level and the visualization level. However, LOD expression gives you an even more control on the level of granularity you want to compute. They can be performed at a more granular level than include granular level, a less granular level, or an entirely independent level. So depending on the granularity. Now, what do you mean by granularity? The level of in-depth filtering that you want. You can perform these operations on the category, be it LOD expressions, basically LOD calculations are of three LOD calculations are of three kinds. First is include, second is exclude, and third is fixed. Okay, include being the most in-depth or most granular LOD calculation, and fixed is the least granular LOD calculation. Okay, so granularity means in-depth. Okay. Now the next one is called the table calculation. Table calculations allow you to transform values at the level of detail of the visualization only. So see, when you apply LOD expression and normal basic expressions, which we did last, that what do we do exactly? We select any one, we select the expression on the entire data source itself, right? So what happens is you change the data, but when you perform table calculation, what happens is you're performing them at the level of visualization. So your entire data will not be affected ever. Only the level of, only at the visualization will change. Okay. I have not seen you how to make a Pareto chart, but a Pareto chart is we'll see it later in the charts module. But in a Pareto chart, what we need is we need a level of visualization. We need to do some calculation, but that will only be affecting the graph that has been made at that particular point of time. Nothing else. Nothing else changes. Okay. So that is an example of table calculation. Now, types of calculation also include some string function. So we saw some of the string functions. Okay. And date functions also, we saw like how to work with date function and all that, how to get month, average, count. We know all of these. Now some of the logical functions available in Tableau are in, and, else if, nd. Okay, now these are like, if I go to explain what are these some of the logical functions, so they basically perform logical operations. Now what do you say, what do you mean by logical operations? The output or the result of these logical operations, they perform some operations in which the output can either be two things, true or false. So you are basically making a condition, and if you are checking whether the condition is true or the condition is false. Okay, so if you see in expression one, in expression two, so if in is a function, logical function, what happens is you are checking whether, let's say you're checking whether in the customer name, if there is a character called ABC. So if you do it something like this, okay, if you write it, so let's say you write something like this. If I'm checking whether in the sales column, if there is any character which matches with ABC, okay, sorry, ABC in my column customer name. So it will check in the column customer name what are the values where the customer name has this substring, which is called ABC. I explained this, the concept of a substring in the last class, which is basically part of the string. Okay, so if you have any column in the, if you have any name in the column customer name with the substring ABC, for those columns it will return true, otherwise it will return false. Okay, so that is the concept of a substring. That's the concept of a in. Okay, returns true if any value in expression one matches any value in expression two. The values in expression two can be a set, a list, or list of literal values, or combined field. So in any situation, you can use this to check whether your any specific condition is being matched or not. Okay. Now, the next, similar to in, we have something called as and operation. Okay. If expr1 and expr2, then and then end. Okay, so you have to understand this basic logic of computer science, which says that if you have two expressions, okay, if you have two expressions, expression one, expression two, Okay, then you can apply different logical operations on these. So on the basis of two expressions, if I apply and, the meaning of and is the expression one, okay, the expression one and expression two. Now let's say I write a final underscore expression, okay, which is a expression one and expression two. So what happens is you have multiple expressions in your calculation. First, it will evaluate this expression, then it will evaluate this expression. And the meaning of this and operation is if this condition is satisfied, that is expression one is satisfied to be true and expression two is satisfied to be true, then only the final expression results in a true. Otherwise, the final expression results in a false. Okay. So and operation works something like this, that a true, true and true is equal to true. In any other situations, if you have only one true or both false, the result is false. Only if both the conditions or both the expressions are resulting into a true, then the final output of the evaluation is true. Okay. So this is called an AND operation. So here in this syntax, if it goes something like this, if expression one is satisfied to be true and expression two, sorry, if expression one is satisfied to be true and expression two is satisfied to be true, then the result has to be then you will specify a specific condition. Okay, that is called AND operation. Now else. So else part we actually did in the last class, where I said that I created a set called top 10 customer set. Now if my customer name is lying in the top 10 customer set, then one, else zero. So that is also a logical function. Similarly, if you have multiple conditions, so let's say what if my if I have top 10, if top 10 customer, then one, if not top 10 customer, let's say then two, otherwise zero. So in that case, you will use something called as else if. Okay, so that is another way to approach this problem, which is called the else if logical function. Okay, and then the ND or logical function, it tests a series of expressions returning the then value for the first true expression. Okay, so let's say you have something like this: if expression then you execute the then part, else if expression two, then two. Like it's basically a combination of multiple if expressions. Okay, so that is called a ND function. Okay, now we have already seen these number functions. We so what is the meaning of absolute? Absolute basically gives you the non-negative. So let's say you write something like this: absolute of 3. So absolute of 3 will give me 3, and absolute of -3 will give me 3. So basically what absolute function does is it returns the absolute value of a given number, and absolute value mathematically is if you pass a positive number, you will get the same number. If you pass a negative number, then you will get the positive of that number. So that is the use of the absolute function. Okay, now going to the next one, a cos. Now this, if you we don't have to go into depth, because this is like a trigonometric function which returns the a cos or cos inverse of a number. So if you, I don't know whether you remember, but there is something called as a cos in trigonometry, which is a ratio. And similarly, there is also something called as cos inverse, which is basically cos to the power -1. So a cos basically returns the cos inverse of a number. Okay. let's say I want to print, I want to highlight it as greater, else if profit is profit is equal to shipment cost, then we say something called as equal, else we can write lesser, and then we write end. Okay, and then we say apply. We close it, we write the name of the subcategory. Okay, let's take the subcategory into rows, and then we can take the sample function into detail. So if you, let's say, change the color. Okay, so basically it is giving me for each of the, let's say if I can highlight it instead of here, I can highlight it here. I don't think, yeah. So it's it is basically now telling me that in which subcategory of product the shipment cost was the, sorry, the sales was greater than the shipment cost. Okay, so if you go here, analysis, and you can see the calculated field that I created. This is a condition where I told you about if, and else. Okay, so I'm checking a condition. If profit is greater than shipment cost, then I should display greater. Else if it should display, if they are equal, then it should display equal. Otherwise, it should display lesser. Okay, so now I'm taking a subcategory. I'm checking which of these products profit is greater than subcategory. Profit is greater than shipment cost. Profit is equal to shipment cost. Profit is less than shipment cost. So in only one subcategory, the profit is equal to shipment cost, which is furnishings. Now, and in all these accessories, okay, uh, now I have to check why it is showing me greater and lesser both in both of these
Yeah.
subcategories. So now it's giving me the correct value, because why it was showing both greater and lesser was because it was taking individual values of profit and shipment cost. So wherever accessories came into picture, like in the entire data set, wherever there was accessories in my subcategory column, and it looked like this. In one case, in one product, in the accessory subcategory, the profit could be greater than shipment cost. In the other case, in the same accessory subcategory, there was a product where the shipment cost was greater than the product profit. So that's why it was showing both greater and lesser, and that is why it was also showing equal. Now what I'm checking is I'm basically checking for only the sum of profit and sum of shipment cost, and in that case I'm getting either the subcategory lies in the greater category or lies in the lesser category. So is it clear now? So this is like the demonstration of the functions which we have seen till now. Similar to that, you can apply mathematical function, but the use case of mathematical functions is very less, like a cos inverse, a cos, a tan, and all that. So that's why I don't think it's necessary for us to go through that. But this we need to know how to make the basic expressions. Okay. So till clear till here. Now the next thing that we need to see is LOD expressions. Now the LOD expressions, and we need to see the concept and the syntax. Okay. So just like basic expressions, LOD expressions allow you to compute values at data source and visualization level. However, LOD gives us more control on the level of detail. Okay. Now, first, how to make an LOD expression? Open Tableau desktop, connect to Superstore, save data source, navigate to new worksheet. From the data pane under dimensions, drag region to the column shelf. Okay. And drag sales to the row shelf. Now, this is a simple bar graph that they have made. Now we will create the LOD expressions. Simple to a calculated. This is again done on the calculated field. We will go to analysis, select create calculated field. In the calculated editor that opens to the following, name the calculation as sales per customer and enter the following LOD expression. Click OK once finished. What we'll do is we will include customer name and sum of sales. So this is our expressions. Okay. Now three things. Okay. Fixed, include. Okay, fine. So let us first understand what is the meaning of include. Include level of detail expressions allow computer values using the specified dimensions in addition to whatever dimensions are in the view. Okay. Include level of detail expressions can be useful when you want to create at a fine level of detail in the database and then re-aggregate and show at a coarser level of detail in your view. Fields based on include level of detail expressions will change as you add or remove dimensions from the view. So I'll try to explain this in simple terms. First, let me try to plot this graph, okay? And what they have done. You can see here. First, I'll take region and I'll take sum of sales. Now I will go to analysis. I'll select on create calculated field and I will say sales per customer. Okay, and here if I go to the where is the PPT? Okay, so here I will write this, okay, and apply. Now, whenever you write an LOD expression or level of detail expression, it always comes inside the curly brackets, and inside the curly brackets I have something called as include. Here either it can be include, exclude, or fixed. So these three things can be there: include or exclude or fixed. And inside include, exclude, or fixed, there will be one column name which will be associated with one of the measure names. So which can be sales or profit or shipment cost or quantity or discount percentage. Now I will click on OK. Now let's me see sales per customer. Let's see if the sales per customer can be added into yeah. So if I try to add sales per customer here. So now see, this is sales per customer in all the regions. This is normal sales and this is sales per customer in each of these regions. So you will see that the values are exactly same. There is no change in the value. Okay. And so here I'll remove this. Guys, sorry for the disturbance outside. So so what include keyword means is that it will consider that, like I have written here, include customer name. So it will include that customer name irrespective of the fact that whatever is the filter. Now, if you can, I don't know whether you've been following what I did till now. So I created a new calculated field which was called sales per subcategory. Inside the sales per category, I included, like I wanted to find out the sum of sales for each subcategory. Now we can do this using a simple visualization also. But let's say you want to use it as a filter or as a differently aggregated tool. So see, you cannot, this is not a specific column, okay, like sales per subcategory. You can only drag and drop the sum of the sales, and when you are using it against subcategory in a visualization, you can use it. But let's say I want it constantly, like at the like a regular axis. So for that I can create something called as sales per subcategory. Now let's say for each subcategory I want to compare the average sales with sales per subcategory. So we are getting here, I'm doing that operation itself. So you can see here, okay, the in the copiers machine the average sales is $2,000, and sales per subcategory for some of the sales for per subcategory is 149. Okay, so similar to that. So that is what is called as like what can be the use of LOD expressions. One category of LOD expression use it, which is called the include expression. Okay. Now, similar to the include expression, you can also use the exclude and fixed expression. So let's say if you want to use, let's say we have want to use it to on the category dimension, okay, and we want to find out the average profit per category, okay, so you can use LOD expression in that case also. Let's say if I here, now this will explain you the difference between include and exclude, okay. So category wise sales. Now category wise profit. So what happens is, again I'll give a pair of parentheses and then I will write exclude, and I will write category. I'll write sum of, and I'll write profit. Okay. Now I'll write it apply. So the meaning of exclude is it will give me a sum of profit on the category. Okay. It will give me a sum of profit on the category, but ignores the effect of the category column itself. So it will consider all the other dimensions on the sum of profit, but it will exclude the effect of the category wise grouping of the profit. So when I say exclude, that means exclude category and all the other dimensions which affect the profit, such as subcategory, shipment mode, segment, region, product name, and all those things. It will include its impact on the sum of profit. So when I write it apply, okay. Okay. Now let's see this. If I drag and drop product category onto the rows and I write sum of sales, okay, I will write it here, and I will write sales per category. Wait 1 second. Category wise profit, yeah. So if I drag and drop it here, so now if I want this, okay, it has done the sum of sales, and it's 1 second. I don't want it in detail, I want it in text. So see here, for category wise profit, or let's say if I don't take sum of sales, here instead of sum of sales, I want to take something like sum of profit, because I'm working on profit. Okay, now see here, category wise profit is 286, but actual profit that I am getting is actually 18,000. So what it means that it is not including the effect of category on the profit value. So it is not, it is actually excluding that category, like furniture, office supplies, and technology. So whatever, what like it is in the case of furniture, what is the subcategory which is making the value of profit value, what is the product name, what is the shipment mode, and all that. So it will exclude the impact of category of products on calculation of the profit, and it will include only the other categories. So everything except category of products will be included to understand the impact of profit on the subcategory. So this is the difference between include and exclude.